Hello everybody and welcome to the homework helper for section 9.4. Let's go ahead and give this thing a look. The opening section is about writing explicit function rules for linear relationships. So this should be mostly review of like unit 1, unit 4, and a couple things we've done recently. But essentially what they're going to do is they're going to give us some partial pieces of information and we have to figure out what the linear relationship is. For example, in number 1, it gives us two pieces of information. It gives us 2 points on a line. And so we have to figure out what the linear relationship is between 3, 7 and 5, 13. Now, there's a couple of linear relationships that we know. We know that there is slope-intercept form, which is your simple y equals mx plus b. And we know that there is the point slope form. And this is going to be your y minus y1 equals m times x minus x1. Either of these will work. Now, given that we're given 2 points, but we're not given an intercept, and remember our intercept is our y-intercept, which is where x equals 0. Because we're not given our intercept, this does not look like the form we want to use. It looks like point slope is what we want to use because we have a couple of points, but we don't have the slope. But we can easily find the slope using the slope formula. The slope formula is delta y over delta x, which means change in y and change in x. So what I'm looking at is I'm looking at how my y values change. And I see that it goes from 7 to 13. So how much of a change is that? Well, that's a change of 6. But the real way we were able to do that is we took our second number, our y2, and we subtracted our y1 from it, right? To figure out how I got from 7 to 13, my brain very quickly did 13 minus 7 to get to 6. And likewise, we want to figure out our change in x, which is we go from 3 to 5, which is 2. But again, very quickly, my brain did my second value, my x2, minus my x1, which is 3. So really what this is I know that my slope is going to be 13 minus 7 all over 5 minus 3. 13 minus 7 is 6, as we said. 5 minus 3 is 2, as we said. And 6 divided by 2 is 3. And so now I have my slope. I have a point. I can use point slope form. So all I have to do is pick a point. I'll pick the first one. Why? Because it's the first one, and I'm a simple dude. So y minus the y value of my first point, which is 7. And then that's going to equal my m, which we just discovered was 3, times x minus the x value of my first point, which is 3, and I have completed the task. And that's it. That's all we're going to be doing for these ones. For these here, it will be more of the same, where all that we need to do is figure out what parts of the equation we have. Now, for both of these, an intercept is given, and so the easiest way is just to find our slope-intercept form, which again was y equals mx plus b. I know, for example, for this one, it's going to be y equals mx plus 10, because that's where my intercept is. All I have to do is figure out my slope. To figure out my slope, I do a slope triangle. To do a slope triangle, all I do is find where it crosses another point. So when I'm just scanning it, here we go, it crosses right here. And so how does it get from this point to this point? Well, I see how it goes down 2 and over 1. So our rise, our delta y is -2. Our delta x, our run, is 1. So I know that the slope is a -2 over 1, which is just simply -2. So y equals -2x plus 10. And I've completed the task. I've written an equation for this. That's it. Again, should mostly be review. Let's go ahead and go on to the next page. So what we're going to be doing with these ones is we're looking at relative frequency tables. Previously, we've done relative frequency tables of the whole table, but what these two problems are going to ask us is to do relative frequency on either our columns or our rows. So when we're looking at these, that's what's going to be most important, is instead of referring to just that bottom corner number, we're going to be looking at it as it refers to each of these columns, or for this one, for each of these rows. Okay, so let's go ahead and get that task started. When I'm looking at this, it says for each two-way frequency, or for each two-way table below, create the indicated relative frequency table and also provide two observations with regards to the data. So this table represents surveys, results from a sample of students regarding mode of transportation to and from school. So I am a boy who rides his bike. So I will use boys and bikes to represent how many of these people come in that way. So when we're looking at the highlighted row here, we realize that this is a frequency of column table. And you can see here, each of these is represented as 100%. So what we're actually looking at when we're looking at, say, our bike column is how does this relate to 100%? So when I'm looking at the boys who ride bikes, I'm not regarding it to the total, but instead I'm regarding it to the total of bike users. So the percentage that I want is I want these two percentages for boys who ride bikes and girls who ride bikes. I want these two percentages to add up to 100. So this plus this should be 100. So what I need to do here is figure out what percent of 69 is 47, right? So when I'm trying to figure out this, I put my part over my whole. And in this case, my part is 47 and my whole is 69. And so all I do is I plug that into a calculator that I have off screen, and I see that I get 0.681159, and I could go on and on and on and on. So what is that as a percentage? Well, whenever, this is it written as a decimal, but whenever we want to find it as a percentage, we just have to put this over 100%. Or the easiest way to do that without having to divide this by 100 is you just move your decimal place over twice. So I would see that this is a 68.1%. Okay, and I don't think it tells us where to round it, but 1 decimal point seems fair. And there we go. I figured out that percentage. And so what we would do now is we would go through all of these and figure out what their relative percentages are. Okay. Number 8 is just slightly different. Number 8 is, this time, instead of caring about how it relates to the column, we're now looking at it as rows. Okay, so now we're seeing how this all relates to the marginal frequency that's in the row. So family size and pet ownerships, I am a family of 4 or less and I have 1 pet. So that's going to be the one that I'm going to look at for this problem. And so when I'm looking at this, again, I'm looking at it just towards the shaded feature, not the total, and not the column like we did last time. So 52 to 172. So my part is 52, my whole is 172. I'll just do that on a calculator off screen real fast. 52 divided by 172, and I see that I get the decimal 0.3023, yada yada yada. Divide that by 100, but again, the easier way is just to move this over 2 decimal places. So it's just going to be 30.2%. So this is going to be 30.2%. And so look at what this is communicating now. This means of families of 4 or less, 30.2% own 1 pet. Okay? Because we're relating it to the total here. So what we really care about, the important information, is families of 4 or less. This is the criteria that we're comparing, and thus 30.2% is an aspect of that. When we looked at our previous example where we were looking at a column, 68.1% of bike riders are boys. That's what it's asking. That's what that information is telling us. It doesn't tell us how many boys are doing anything. And in fact, when we go through all of these will not add up to 100%. So again, this is just focused on the column. This is just focused on the row. And then you'd go ahead and go through and fill in for everything else. All right, last section here. Okay. So this is like the one we did in class a couple days ago. It says the two-way table below contains survey about boys and girls' shoes. Find the relative frequency of the whole table. So when we're doing the relative frequency of the whole table, this time we're only focused on the whole. This time, this is the only thing that's 100%. So I am a boy who wears, I guess, dress shoes sometimes. I sometimes wear athletic shoes too, so I'll do both. I don't really wear boots unless it's snowing. All right, so I'll start with athletic shoes. So again, part over whole. My part over whole here is 50 over 192. 50 over 192 is 0.260. When I divide this by 100, it is 26%. And so I'm going to write 26.0%. The reason I write 0.0 is because this entire process, we've been doing it to that tenths place or that first decimal place. So if it naturally rounds to 0, it's significant. That's a significant number because every other one we've done, we've rounded to that decimal. So it's important to say that that decimal is a 0 because we're not rounding it to the whole, we're rounding it to this place. Okay. But I'll do the same thing for dress shoes. Dress shoes is going to be 10 divided by 192. 10 divided by 192, part over whole, gives me 0.052. When I divide that by 100, or just move it over, I get 5.2%, etc., etc. So on the days where I wear my sneakers, I'm like 26% of the population, of the total population, because 26% of us are boys who wear athletic shoes. On the days I wear my dress shoes, I'm like 5.2% of the population because I'm a boy who is wearing dress shoes, and that's how it relates to the whole population. And there you go. And then finally, this is another review section. It's one variable statistical measurements and comparison. It wants us to find the mean, the median, the mode, the range, and we'll skip standard deviation. I'm not that interested in standard deviation, but I do want you to create either a box and whiskers or a histogram for these. And remember, mean is where we add up all the numbers. You know, we add them all up. So we have like term 1 plus term 2 plus term 3 plus term ... n. And what we're going to do is once we have all of these different terms, we'll then divide it by n, and that will be our mean. Our median is when we line everything up from lowest value to highest value and then find the midpoint. Our mode is the most common occurring number, and our range would be from low to high. And that's it. All right. Good luck, woodchucks, and I'll see you tomorrow.